Okay, so ready to dive deep again. Today's topic is, well, it's cosmically huge. It's all about dark energy. You know, that mysterious force that's been making the universe expand faster and faster.
You got it. And we're going right to the source for this one, pulling directly from, you guessed it, the Wikipedia page on dark energy.
A classic. And our goal today is to break this down. We'll explore what dark energy is, the evidence that it really exists, and the biggest mysteries that are still, well, puzzling scientists.
We really want to focus on the why and the how of what we currently understand so it's clear for everyone.
Right, because this stuff is mind-boggling. I mean, think about this. Everything we can see, everything we know, all the stars, planets, even us, it all makes up less than 5% of the universe.
Less than 5%. It's incredible.
It's wild. So where's the other 95%? Well, that's where dark matter and this even more mysterious dark energy come in.
Dark matter takes up about 26%, and then dark energy is the big one, coming in at around 68%.
So dark energy is the dominant force in the universe. But what exactly is it?
Well, at its core, dark energy is this proposed form of energy. And it's not like the energy we're used to. It acts on the universe at the largest scales.
And its main effect.
It's pushing the universe to expand, and it's doing so at an accelerating rate.
So everything's moving apart faster and faster.
Exactly. But here's the weird part. While it's pushing everything apart, it seems to be slowing down how structures like galaxies and galaxy clusters form.
It's like a cosmic tug-of-war.
That's a good way to put it. And to make things even more interesting, its density is incredibly low.
How low are we talking?
Around 1030 grams per cubic centimeter. That's way less dense than the matter we see in galaxies. But because it's spread out everywhere across all of space, it becomes the dominant force.
So it's like a faint pressure pushing everything outward?
Mm-hmm.
But how did we even get to this idea of dark energy? It's not like someone just woke up one day and said, hey, there's this mysterious force.
Right. It's a fascinating story that starts way back with the idea that gravity should be slowing down the expansion of the universe.
That makes sense. Gravity pulls things together.
Right. But then Einstein came along with his theory of general relativity and introduced this thing called the cosmological constant.
I've heard of that. Wasn't that his biggest blunder?
He hauled at that, yes. But it's more complicated than that. He initially added it to his equations to describe a static universe, one that wasn't expanding or contracting.
So it was a way to balance gravity and keep the universe stable.
Yeah, that was the idea. He thought of it as the energy of empty space, what we now call vacuum energy. But then, of course, Hubble came along and showed that the universe is actually expanding.
So much for a static universe.
Exactly. And Einstein kind of abandoned the cosmological constant. But the idea didn't completely disappear. It popped up again, but this time in a different context, the very early universe.
Okay, so how does dark energy fit into the very beginning of the universe?
Well, in the 1980s, this idea of inflationary dark energy emerged. It was proposed that in the first fraction of a second after the Big Bang, a field with negative pressure, similar to dark energy, caused the universe to expand incredibly rapidly. This period is called cosmic inflation.
So dark energy was super powered in the early universe.
It was, but at a much higher energy density than what we see today, and it ended very quickly. The exact link between this early inflationary dark energy and what we observe now is still not clear.
It's like a whole other chapter in the dark energy story.
It really is. But then, fast forward a few billion years, and the focus was on matter, both regular matter and dark matter, gradually slowing down the expansion. But that picture didn't quite fit with the data.
What didn't add up?
Well, most inflation models predict that the total density of matter and energy in the universe should be just right for a flat universe, but the matter we observed wasn't enough. Plus, the measured Hubble constant, the expansion rate, was off. And the way galaxies clustered didn't perfectly match the models either.
So something was missing from the equation.
Exactly. And then came the game changer in 1998, direct evidence that the expansion of the universe wasn't slowing down, it was speeding up.
Wow, that must have been a huge shock. How did they figure that out?
It was a major discovery. Two independent teams were studying these super bright exploding stars called Type Ia supernovae.
I've heard of those. Aren't they like cosmic lighthouses?
You got it. They have a very consistent brightness, so we can use them to measure distances across the universe. And when they compared the distances and the redshifts of these supernovae, it was clear the expansion was accelerating.
So the universe is not just getting bigger, it's getting bigger faster and faster.
And that's where the idea of dark energy really took off.
And with it, The lambda CDM model, right?
Exactly. It includes both cold dark matter and a cosmological constant represented by lambda to account for dark energy.
And because this model explains so many observations so well, it's now considered the standard model of cosmology. It's like the gold standard.
It is. And it's worth noting that the term dark energy was coined around this time in 1998 by cosmologist Michael Turner.
So supernovae gave us the first big clue. But there's more evidence for dark energy, right? It's not just based on one type of observation.
Absolutely. The evidence has continued to pile up from a variety of sources. Let's start with the cosmic microwave background, or CMB for short.
The afterglow of the Big Bang.
Precisely. Experiments studying the CMB, like Boomerang and Maxima in 2000, showed that the total density of the universe is very close to the critical density needed for a flat universe. And then, in 2001, the 2DF Galaxy Redshift Survey gave us a pretty precise measurement of the matter density.
And what did it show?
It showed that matter only makes up about 30% of the critical density. That leaves a big chunk unaccounted for.
And that missing chunk is?
Dark energy. It fits perfectly because it doesn't clump together like matter. The WMAP satellite and the Planck spacecraft later gave even more precise measurements, confirming that dark energy makes up around 68%. It's like the missing piece of the cosmic puzzle.
The universe's budget wouldn't balance without it.
Right. And then there's the evidence from the large-scale structure of the universe, the way galaxies and galaxy clusters are distributed.
So how does the structure of the universe point to dark energy?
Well, our models for how these structures form suggest that we don't have enough matter to explain what we see. We need something else, like dark energy, to influence this cosmic architecture.
It's like dark energy is shaping the universe on a grand scale.
It is. And the 2011 Wiggle-Z Galaxy Survey, which mapped over 200,000 galaxies, gave us independent confirmation of cosmic acceleration stretching back about 7 billion years.
How did they do that?
They use these things called baryon acoustic oscillations.
Try saying that 3 times fast.
Yeah, it's a mouthful. Essentially, they are sound waves from the very early universe.
Sound waves from the Big Bang.
Yep. And these sound waves left their mark on the distribution of galaxies. They act like standard rulers, allowing us to measure vast cosmic distances.
It's like the universe has its own Duntan measuring sticks.
Exactly. And these measurements independently confirm that the universe's expansion is accelerating.
So that's more evidence for dark energy. And you mentioned the CMB earlier. How does that support dark energy beyond just the density measurements?
It does. And it's all about those tiny temperature variations in the CMB, the anisotropies. These variations tell us that the universe is flat.
Flat. Like a pancake.
Well, not exactly. It means that the geometry of space-time is flat. And for that to be true, the total mass energy density of the universe needs to be a specific value, the critical density. But matter alone doesn't account for all of it. We need dark energy to make up the difference and achieve this flatness. The CMB data from WMAP and Planck have given us very precise measurements, consistently showing that dark energy accounts for around 70%.
So the universe's shape itself tells us that dark energy must exist. That's pretty amazing.
It is. And there's another fascinating effect called the late-time integrated Sachs-Wolf effect, or ISW effect for short.
Okay, what is that one?
It's a bit subtle. Basically, as photons from the CMB travel through the universe, they encounter these gravitational wells and hills created by galaxy clusters and voids.
So the gravity of these structures affects the CMB photons.
Yes. But here's the key. Because of dark energy and the accelerated expansion, these gravitational wells and hills are subtly changing over time, and this leaves a small imprint on the energy of the CMB photons.
So dark energy is like subtly warping the fabric of space-time, and we can see its effect on the oldest light in the universe.
That's a great way to put it. And what's fascinating is that by measuring these subtle changes, we get a direct signal of dark energy influencing the universe.
That's incredible. It's like dark energy is leaving its fingerprints on the CMB.
Exactly. And finally, we have what's called observational Hubble constant data, or OHD. It's also sometimes referred to as using cosmic chronometers.
Cosmic chronometers, that sounds cool. What are those?
They're essentially special types of galaxies that we can use as clocks to measure the expansion rate of the universe at different points in time.
So it's like having time machines to look back at how fast the universe was expanding in the past.
That's the idea. And these measurements give us a direct way to track the expansion history and provide yet another independent line of evidence for accelerated expansion, pointing to dark energy.
Okay, so we've got supernovae, the CMB, large-scale structure, and cosmic chronometers. It's a lot of independent evidence pointing to dark energy. But Knowing it exists is one thing, figuring out what it is a whole other challenge, right?
Absolutely. The evidence for its existence is strong, but its true nature remains a mystery.
And that's where things get really interesting. So what are the leading theories about what dark energy might actually be?
Well, the most straightforward idea is to go back to what Einstein proposed, the cosmological constant. It's basically saying that empty space itself has energy, a vacuum energy.
So even nothing has something.
In a way, yes. And because energy and mass are equivalent, think EMCI, this vacuum energy would exert a gravitational effect. And if it's constant and positive, it would cause the universe to expand faster and faster. That's the lambda and the lambda CDM model.
Sounds simple enough, but I remember you mentioning a big problem with this idea.
Right. It's called the cosmological constant problem. Our best theories about the quantum world predict a ridiculously large value for this vacuum energy, like way, way bigger than what we observe. It's off by a factor of 120 orders of magnitude.
120 orders of magnitude. That's not just a little off.
Not at all. It's like saying an atom should weigh more than the entire observable universe. So something's not quite right with our understanding of vacuum energy. It could be that our theories are incomplete, or there's some unknown mechanism that cancels out most of this energy, leaving just a tiny bit to cause the acceleration we see.
So the cosmological constant is a bit of a head-scratcher. What are some of the alternative theories?
One of the main contenders is called quintessence.
The quintessence, that sounds almost mystical.
It does have a ring to it, right? But it's basically the idea that the acceleration is driven by the potential energy of a dynamic scalar field.
Okay, break that down for me.
Think of it as a field that permeates all of space and can change over time. Unlike the cosmological constant, which is fixed, quintessence can evolve.
So it's more flexible.
Yes, exactly. And this field would need to be very light, so it doesn't clump like matter.
So it's kind of like a ghost-like field pushing the universe apart.
That's a pretty good analogy. And while we haven't detected it directly, quintessence can lead to some interesting predictions, like tiny violations of Einstein's equivalence principle, and maybe even slight variations in fundamental constants over time.
So our understanding of gravity might not be the whole story, but does quintessence have its own set of issues?
It does. One of the big ones is the coincidence problem. Why did the acceleration of the universe start when it did, around 5 billion years ago? If it had started earlier, galaxies might not have had enough time to form.
That would be a big problem for, us being here.
Exactly. Some quintessence models try to explain this with tracker behavior, where the energy density of the field follows the dominant component of the universe, first radiation, then matter, and finally takes over, causing the acceleration.
So it's like dark energy has been playing a long game, waiting for its moment to take the lead.
Right. There are also variations of quintessence, like phantom energy. It's even more extreme, where the energy density increases over time. This could eventually lead to the universe tearing itself apart in a big rip.
A big rip? That sounds dramatic.
It does. And then there's K-essence, which involves different kinds of kinetic energy for the scalar field. But what's really cool is that recent research has suggested that some quintessence models might actually work better than the cosmological constant, especially considering some of the current debates about the exact value of the Hubble constant.
So quintessence is a strong contender. Are there any other big ideas trying to explain dark energy?
Another fascinating avenue is interacting dark energy. These theories try to connect dark energy with other mysteries of the universe, like dark matter.
So maybe dark matter and dark energy are somehow linked.
Exactly. Some models explore the idea that dark matter can decay into dark energy. There are also theories that modify gravity itself on cosmic scales.
So instead of adding a new thing, they're tweaking the laws of gravity.
Precisely. And some have even considered whether dark energy might interact with regular matter, though that's hard to prove. Remember that excitement about the XENN1T experiment a while back?
The one that was looking for dark matter.
That's the one. Some thought it might have detected a sign of dark energy interacting with matter, but that turned out not to be the case.
Oh, bummer. But it's good they're looking into all possibilities.
Absolutely. And there's another class of models called variable dark energy models.
Variable, so it changes over time.
Exactly. These models suggest that the energy density of dark energy might not have always been the same. It could have evolved.
So dark energy might not be a constant force after all.
It's possible. Cosmologists are using data from baryon acoustic oscillations and supernovae to try to figure out if and how the equation of state of dark energy might have changed over time. And there have been some early hints from the Dark Energy Spectroscopic Instrument, or DEI, that maybe dark energy is evolving.
It's incredible how much data we're gathering.
It is. But we need more to be sure.
So we've got all these different theories. But is everyone convinced that dark energy is real? Are there any scientists who think it might be something else entirely?
There are definitely alternative explanations out there, although they haven't gained widespread support. One idea is called inhomogeneous cosmology. It basically says that maybe we live in a particularly empty region of the universe.
So we're in a cosmic void, and that's skewing our measurements.
That's the idea. And because of that, we might be misinterpreting the local expansion rate as a global acceleration driven by dark energy.
Interesting. Any other alternative ideas?
There's also the concept of a cosmological extension of the equivalence principle. It suggests that space might expand faster in voids, which could create the illusion of overall acceleration.
So maybe it's not dark energy, but just weird things happening in empty space.
Some think so, but there are good counter-arguments to these ideas. There was even an experiment specifically designed to detect a force associated with dark energy in the lab, but it found nothing.
Okay, so the lab test didn't pan out. But didn't I read something about a new theory connecting black holes to dark energy?
Yes, it's a recent one proposed by researchers at the University of Hawaii in 2023. They looked at rotating black holes and found that if you connect them to the expanding universe in a specific way, they would gain mass as the universe expands. And the rate at which they'd gain mass would make their energy density constant, just like dark energy.
So black holes could be contributing to the expansion. That's wild.
It's a very cool idea, but it's still early days. Many scientists are skeptical because this theory needs to explain other observations too, not just the accelerated expansion.
It's definitely something to watch. But what about the possibility that it's not dark energy, but something wrong with our understanding of gravity itself?
That brings us to modified gravity theories. They propose changes to Einstein's theory of general relativity, especially on cosmic scales.
So maybe we need to tweak our understanding of gravity to explain the acceleration.
That's the idea. But there are a lot of constraints on these theories. The detection of gravitational waves from merging neutron stars in 2017, the GW177817 event, was a big deal.
I remember that. Gravitational waves and light arriving at almost the same time.
Exactly. And that ruled out many modified gravity theories that predicted different speeds for gravity and light.
So modified gravity is facing some hurdles.
It is. But while some scientists continue to explore those avenues, most agree that the evidence for dark energy within general relativity is currently the most compelling. It simply fits the data better.
Okay, so dark energy seems to be the leading explanation. But what does all this mean for the future of the universe? If this expansion keeps accelerating, where does it all end?
The fate of the universe is intrinsically linked to the nature of dark energy.
So depending on what dark energy is, we could be headed toward different endings.
Exactly. If it's a cosmological constant and the acceleration keeps going, all those galaxies outside our local group will keep moving away faster and faster. Eventually, they'll be so far away that their light will never reach us.
So we'll be left alone in a vast, dark universe.
In a way, yes. Our local group will stay together because of gravity, but everything else will eventually disappear beyond the cosmic horizon. And even in our little corner, things won't be so great. The universe will become colder and colder as it expands, leading to a heat death.
That's a pretty bleak picture.
It is, but remember, that's just one scenario. If dark energy turns out to be phantom energy, things could be much more dramatic. The acceleration could get so strong that it rips apart everything, from galaxies to atoms, in a big rip.
Okay, that's definitely not a good ending. Are there any more optimistic possibilities?
There are some theories that suggest dark energy could weaken over time or even become attractive, which could lead to the universe collapsing back on itself in a big crunch. There are even ideas about a cyclical universe with repeated big bangs and big crunches.
So the universe could be like a cosmic boomerang.
It's a cool idea, but it's important to remember that these more extreme scenarios are not supported by the current data. For now, the cosmological constant and continued expansion seem to be the most likely path.
It's a lot to wrap our heads around.
It definitely is. And our source material touches on a philosophical perspective on all of this, which I think is worth considering.
Okay, let's get philosophical.
Astrophysicist David Merritt argues that dark energy might be what's called an auxiliary hypothesis. Basically, it's an idea added to a theory to explain observations that don't fit otherwise. He suggests that dark energy might not be a real entity, but more like a placeholder for something we don't understand yet.
So maybe we haven't truly explained dark energy. We've just given a name to a mystery.
That's his point. But it's important to note that not all scientists agree with this view. Many believe that the multiple lines of evidence strongly suggest that dark energy is real, even if we don't fully understand it.
It's a debate about the nature of scientific discovery itself.
Exactly.
Well, this has been a truly mind-bending journey into the world of dark energy. To recap, dark energy is thought to make up around 68% of the universe, and it's pushing everything apart at an accelerating rate. The evidence for it is pretty strong, but we're still not sure what it is. The cosmological constant is the simplest explanation, but it has some big theoretical problems. Quintessence is another interesting possibility, where dark energy is a dynamic field that changes over time.
And the fate of the universe hangs in the balance, depending on what dark energy turns out to be.
It's amazing to think that we've learned so much about the universe, yet this dominant force that's shaping its destiny remains a mystery.
It's a humbling thought, isn't it?
It really is. And it makes you wonder, what other fundamental forces or components of reality are we missing? What else is out there that we haven't even imagined yet? This deep dive into dark energy is a great reminder that our journey of discovery is far from over. Thanks for joining us on this cosmic adventure.
Okay, so today we're taking a deep dive into Naruto,
Naruto, yeah.
which is a pretty huge anime series
It's massive.
based on the manga of the same name.
Right.
And it's, really made a mark on, like, global pop culture.
Oh, yeah, definitely. It's, it's one of the most popular anime series of all time, and it's had a huge impact on not just anime, but pop culture in general.
Yeah, and we're going to be looking at, like, how the anime kind of, like, came to be and all the, like, big moments and stuff along the way.
Yeah, like how it kind of took those like static panels of the manga and like breathed life into them,
Yeah.
and gave it this whole other dimension for fans.
And I guess for people who haven't seen the show, like, maybe they've heard of it but haven't seen it,
Right.
the anime is kind of broken up into, like, two main parts.
Two main chunks, yeah.
So the fourth part is just called Naruto,
Right.
and that follows Naruto Uzumaki's, like, preteen years.
Yeah, all those early adventures.
And then the second part is called Naruto Shippuden, and that's when they're teenagers and, like,
Things get real.
yeah, things get a lot more serious.
It goes to a whole other level. Yeah.
And, I think it's worth noting, too, that, the animation for Naruto was done by Studio Pierrot.
Yeah, they're a pretty prolific studio known for a lot of popular series.
And then production was by Aniplex.
Right?
And then for North America, Viz Media handled, like, all the licensing and stuff.
Yeah, they're like the gatekeepers for bringing Naruto to the West.
And then, I guess at the heart of the story, like, the main character is Naruto Uzumaki.
Right, he's our protagonist, the underdog ninja with big dreams.
Yeah, he wants to become Hokush.
The leader of his village, the top dog ninja.
Yeah, so basically our mission today is to, like, kind of give you the essential understanding of the Naruto anime.
Exactly, like we're going to cut through all the filler arcs and stuff.
Yeah, we're not going to go into, like, every single detail.
They'll just give you like the core, the essence of Naruto.
Yeah, so you can kind of, like, understand the series without
having to watch all 500 episodes.
Yeah, exactly.
Well, at least not right away.
So where do we even start with this thing?
Well, I mean, the most logical place to start is with the beginning, right?
Okay.
So the first part of the Naruto anime, what we often call like part one.
Part one.
That ran from October 2002 to February 2007
Okay.
with a whopping 220 episodes.
Oh, wow. So that's, like, a lot of Naruto right there.
It's a big chunk of his early adventures.
Yeah, and so, like, how closely did those early episodes follow the manga?
So the first 135 episodes pretty closely adapted the first part of Masashi Kishimoto's manga.
Okay.
But then to give Kishimoto like some breathing room and let the manga continue, the anime kind of went off on its own
Oh,
for the remaining 85 episodes.
wow. So they were, like, making up their own stories?
Yeah, basically they were creating anime-exclusive storylines.
Wow, that's interesting.
It's a pretty common strategy, actually.
Oh, okay.
When you're adapting a popular manga that's still ongoing,
Makes sense?
you need to kind of, buy some time and keep the anime going
Yeah.
while the manga catches up.
So who were the people behind those early episodes?
So the main director was Hayato Date.
Okay.
And Kishimoto actually specifically requested Tetsuya Nishio as the character designer.
Oh, wow, really?
Yeah. which is kind of cool.
So he had a lot of influence over, like...
Yeah, he really wanted to make sure his characters were represented well in the anime.
Yeah.
You know, he had a very specific vision.
That's pretty awesome.
Yeah.
What about the writing?
So for the first 135 episodes, the screenwriter was Katsuyuki Sumisawa.
Okay.
And then when they moved to those original storylines, Junki Takegami took over the writing.
Okay, cool.
And of course, we can't forget about the music.
Yeah, the music in Naruto is, like...
So good.
So good.
Right.
It's, like, so memorable.
So for part 1, the music was composed by Musashi Project and Toshi Masuda.
Yeah, they did such a good job of, like, creating the atmosphere and, like...
Yeah, their music really captured the energy and the emotion of the series.
Yeah, and it's like, you know, it's just so iconic. You know what I mean?
Totally.
So for someone who's, like, never seen the show...
Yeah.
What's the, like, basic story of Naruto Part 1?
Okay, so it all starts with this big, dramatic event.
Okay.
The nine-tailed fox.
The nine-tailed fox,
A
yes.
super powerful demon fox attacks the Hidden Leaf Village.
Right.
And to protect everyone, the fourth Hokage, this is Naruto's dad, he seals the Nine Tails inside his own newborn son, Naruto.
Oh, wow. So that's why everyone's, like, afraid of him?
Exactly, because they know he's got this demon fox inside him.
Right.
But Naruto himself doesn't even know about it
Whoa.
until he's like 12 years old.
Okay.
And this rogue ninja Mizuki reveals the truth to manipulate him.
Oh, man, that's messed up.
Yeah, but it actually kind of backfires on Mizuki because Naruto ends up like fighting him and defeating him.
Okay.
And that earns him the respect of his teacher, Iruka Umino.
Oh, that's cool.
Which is like a really important moment for Naruto.
Yeah.
Because he's finally getting some recognition.
Yeah, he just wants to be accepted.
Exactly.
So what happens next?
Well, after that, Naruto graduates from the Ninja Academy and he gets put on a team.
A team, okay.
Yeah, Team 7?
Team 7 with Sasuke Uchiha.
Sasuke?
Yeah, who becomes his, like, biggest rival.
Oh, wow.
And Sakura Haruna,
Sakura?
who Naruto has a crush on.
Oh, okay.
And their sensei is this cool and mysterious ninja, Kakashi Hatake.
Kakashi, yeah, he's awesome.
Yeah, so they go on all sorts of missions together.
Okay.
You know, at first they're kind of like, you know, D-rank missions, chasing cats and stuff.
Oh, yeah. Gotta start somewhere.
But then they start getting more serious missions. You know, like protecting people and fighting other ninjas.
Okay, so they're like learning the ropes of being a ninja.
Exactly, and their teamwork is really put to the test during a mission in the Land of Waves.
Oh, yeah, I remember that arc.
It's a good one.
Yeah.
And after that, Kakashi decides they're ready for the Chunin exams.
The Chunin exam?
Yeah, it's like this big competition where ninjas can get promoted to a higher rank.
But things take a dark turn when Orochimaru, this like super creepy snake ninja.
Orochimaru, yeah, he's
a bad guy.
Yeah, he's scary.
He invades Konoha and the third Hokage ends up dying.
Oh, no.
Yeah, it's a huge turning point in the series.
Yeah, it's like everything changes after that.
Right, it really shakes things up.
So what happens then?
Well, they need a new Hokage.
Right.
So they asked Jiraiya, one of the legendary Sannin,
Okay.
to become the fifth Hokage, but he turns it down.
He does, okay.
Yeah, but he does agree to go find Tsunade.
Tsunade.
Yeah, she's another one of the Sannin.
Okay.
And they think she'd be a good Hokage.
Okay.
So Naruto goes with Jiraiya on this journey and starts training with him.
Oh, wow. So he's like really getting serious about his training now.
Yeah, he's ready to step it up.
Cool.
And meanwhile, Sasuke is dealing with his own issues.
Right, because Sasuke's brother Itachi comes back.
Yeah, and Itachi like totally kicks Sasuke's butt.
Oh, man.
Which leaves Sasuke feeling like, you know, weak and powerless. Yeah. So he ends up leaving Konoha to train with Orochimaru.
Oh, no. He went with the bad guy.
Yeah, he thinks Orochimaru is the only one who can give him the power to defeat Itachi.
Oh, wow.
It's a pretty big decision.
Yeah. And I mean, Naruto doesn't want him to go.
Of course not. They're like best friends, rivals.
Yeah.
So Tsunade, who by now has become the fifth Hokage,
okay,
she sends a team to try and bring Sasuke back.
Okay.
But they're not successful.
Oh, man.
So Naruto decides to train even harder.
Okay.
And he leaves Konoha with Jiraiya to train for 2.5 years.
Wow, so that's like the end of part 1.
Yeah, that's basically how part 1 ends.
Wow, okay, so how did people outside of Japan get to see Naruto?
So Viz Media got the licensing rights for North America.
Okay.
And the English dubs started airing on Cartoon Network and YTV in September 2005.
Oh, wow. So it came out pretty quickly.
Yeah, it actually gained popularity pretty fast.
Okay.
And then the Cartoon Network broadcast ran until December 2009.
Okay.
They actually didn't air all of the episodes.
Oh, really?
Yeah, they only aired 209 out of the 220.
Oh, interesting.
Yeah, and it was also shown on other channels like Jetix and SABC2.
Oh, wow. So it was like all over the world.
Yeah, it was getting pretty big.
Yeah.
And the DVD releases started in 2006.
Okay.
And there were, like, censored versions for TV.
Okay.
And then uncensored versions on DVD.
Oh, wow. So, like, different levels of...
Yeah, they had to make it appropriate for different audiences and, like, broadcast standards and all that.
Yeah, that makes sense.
And for people who are into streaming, you could also watch it on Hulu, Juiced, and Crunchyroll.
Oh, cool.
And they often had the original Japanese audio with English subtitles.
Okay, cool.
And then later on in 2009, they started re-airing a remastered HD version in Japan called Naruto Shonen Hen.
Okay.
It was basically like a prettier version of the original series.
Cool.
So yeah, part 1 of Naruto, it really like laid the groundwork for everything that came after.
Yeah, it was like a phenomenon.
Totally.
So let's move on to Shippuden.
Okay.
When did that start?
Shippuden premiered in February 2007.
Okay.
Like right after the original series ended.
Okay, so no break.
Nope. They jumped right into it.
Cool.
And it ran all the way to March 2017.
Wow, that's a long time.
It is a long time.
A lot of episodes.
500 episodes to be exact.
500, that's a lot.
It's a lot of Naruto.
And did Shippuden follow the manga as well?
Yeah, it picks up right where the manga's part 2 starts.
Okay, so like right after the time skip.
Exactly.
Cool. So who was in charge of Shippuden?
So Hayato Date was the main director again.
Okay.
Although, you know, with so many episodes, there were obviously other directors who worked on specific episodes.
Yeah, that makes sense.
And Junki Takegami was the main writer for a lot of the series.
Okay.
But there were also other writers involved as well.
Okay.
And the music for Shippuden was done by Yasuharu Takanashi and his group Yaiba.
Oh, yeah, their music is like...
So epic.
So epic.
It's got that like really intense orchestral sound.
Yeah, and like a bit of rock in there too.
Yeah, it's a really cool blend. It really fits the tone of Shippuden. It's like a whole other level of intensity compared to the first part.
Yeah, so for people who haven't seen Shippuden yet, what's the like main story?
Okay, so the title Shippuden, it means Hurricane Chronicles.
Oh.
So that kind of gives you a hint that things are going to be a bit more...
intense.
Yeah, intense.
Yeah.
So Naruto comes back to Konoha after training with Jiraiya for 2.5 years.
Okay.
And he's like way stronger now.
Okay.
But he's also got a bigger target on his back.
Oh, why is that?
Because the Akatsuki.
The Akatsuki?
Yeah, this group of like rogue ninjas.
Okay.
They're hunting down the tailed beasts.
The tailed beasts, right?
Yeah.
Those are like the
super powerful demons.
Yeah.
And Naruto's the Jinchuriki of the Nine-Tails.
So he's like their main target.
Pretty much.
Oh, man.
Yeah, so the Akatsuki is like a major threat throughout Shippuden.
Okay.
And eventually Team 7 gets back together.
They do? Okay.
Yeah, but things are different now.
Okay.
You know, they've all grown up and changed, but they're still trying to find Sasuke.
Oh, right. He's still out there with Orochimaru.
Yeah, and Sasuke's story gets really complicated in Shippuden.
Okay.
He's like on this dark path of revenge.
Oh, wow.
Yeah, first he wants to kill his brother Itachi,
Right?
but then he learns the truth about what happened to the Uchiha clan.
Oh, right. The massacre.
Yeah, and it turns out Itachi wasn't really the bad guy.
Oh, wow.
Yeah, it's a huge revelation.
Yeah, that's a big twist.
And after that, Sasuke decides he wants to destroy Konoha.
When he wants to destroy his own village.
Yeah, he's pretty messed up at this point.
Wow.
But meanwhile, the Akatsuki is still out there doing their thing.
Right.
And they managed to capture 7 of the 9-tailed beasts.
7? Oh, wow.
Yeah, they're really powerful.
So what happens to the Jinchuriki?
Most of them die.
Oh, no.
Yeah, it's pretty brutal.
Wow.
But Gaara, the Kazekage of the Sand Village, yeah, he survives.
Oh, okay, that's good.
Yeah.
So things are like really escalating.
Oh, yeah. It's about to get crazy.
Okay.
So all this leads up to the 4th Shinobi World War.
The 4th Shinobi World War.
Wow. It's basically all the major ninja villages teaming up
Okay.
to fight the Akatsuki.
Wow, that's like a huge battle.
It's massive.
Okay.
And during the war, we learn about some new characters.
Okay.
Like Obito Uchiha.
Obito?
Yeah, he's been manipulating things behind the scenes.
Oh, wow.
And then it turns out the real villain is this ancient being named Kaguya Otsutsuki.
Kaguya, okay.
Yeah, she's like super powerful.
Wow.
And she's connected to the origins of chakra.
Oh, wow. So like the source of all ninja power.
Exactly.
Wow, so how do they defeat her?
It takes like everyone working together.
Okay.
Team 7 Obito. Even Sasuke eventually comes around.
Oh, wow.
And they manage to seal her away.
Okay, so they win the war.
They do, but it's not over yet.
Oh, what happens?
Sasuke decides he wants to reshape the ninja world in his own image.
Oh, no.
Yeah, he's got some pretty radical ideas.
Wow, so what does Naruto do?
They have one final battle.
Oh, wow. This is like their final showdown.
Yeah, it's epic.
Okay.
And it's really emotional.
I bet.
Yeah.
Well, who wins?
Naruto wins in the end,
Okay.
but it's not about winning for Naruto.
What do you mean?
He wants to save Sasuke.
Oh, right, because they're friends.
Yeah, and
Okay.
eventually Sasuke realizes he was wrong.
Oh, that's good.
Yeah, and he comes back to Konoha.
Wow. So what happens after the war?
Well, Kakashi becomes the 6th Hokage for a while,
Okay.
and then finally Naruto achieves his dream.
He becomes Hokage.
He becomes the 7th Hokage.
Wow.
And the series ends with a glimpse into the future,
Okay.
showing the next generation of ninjas and the peace that Naruto has helped to create.
Wow, that's a pretty satisfying ending.
It is, yeah.
So how did Shippuden get released in English?
So Viz Media started screaming subtitled episodes in 2009.
Okay.
And then the English dub premiered on Disney XD in October 2009.
Oh, wow. Disney SD.
Yeah,
Okay.
but they only aired the first 98 episodes.
Oh, really?
Yeah, and then Viz Media's own streaming service, Neon Alley, picked it up
Okay.
from episode 99. Okay.
But then Neon Alley shut down in 2016.
Oh, wow. So it was like all over the place.
Yeah, it was a bit messy.
Okay.
But thankfully, Adult Swim's Toonami block started airing Shippuden from the beginning in 2014.
Oh, cool.
Yeah, and it's been running there pretty consistently ever since.
Okay, that's good.
So that's been like a good way for fans to watch the dub.
Yeah.
And of course, there were also DVD and Blu-ray releases.
Okay, cool.
So yeah, Shippuden had a bit of a bumpy ride in terms of its English release.
Yeah, but it eventually found a home.
Exactly.
So, what about the movies?
Okay, so there were 11 Naruto movies in total.
11. Wow.
3 of them were set during the original Naruto series,
Okay.
and the other 8 were during Shippuden.
Oh, okay, cool.
They were mostly like standalone stories
Okay.
or like
Yeah.
side stories that didn't really affect the main plot.
Okay, cool.
But they were still fun to watch.
Yeah.
Like the first movie, Ninja Clash in the Land of Snow.
Okay.
That was a pretty cool one.
Okay.
And it came with a bonus OVA.
Yeah, it was a funny one with all the ninjas competing in a sports festival.
Oh, that's awesome.
Yeah.
What about any other notable movies?
Well, Road to Ninja, Naruto the movie, that one's really interesting
Why is that?
because Kishimoto himself was really involved in making it.
Oh, wow.
Yeah, he helped plan the story and design the characters,
Okay.
and it's like an alternate universe story.
Oh, cool. It's like a what-if
Yeah.
scenario.
Exactly.
Oh.
And then there's the last, Naruto the movie.
Okay.
That one takes place after the manga ends, but before the epilogue.
Okay.
And it focuses on Naruto and Hinata's relationship.
Oh, cool. So like a romantic story?
Yeah. And Kishimoto was involved in that one too.
Okay.
So it's considered canon.
Oh, okay, cool.
And then there's Boruto, Naruto the movie.
Naruto. Okay.
Yeah, that one focuses on Naruto's son, Boruto.
Okay.
And Kishimoto was heavily involved in that one as well.
Okay.
He basically set the stage for the Boruto sequel series.
Cool.
So yeah, the movies are definitely worth checking out, especially if you're a fan of the series.
Yeah.
And then there are also the OVAs.
The OVAs, right?
Yeah, there were 12 of those.
Oh, okay.
They were mostly like shorter stories
Oh,
or
okay.
like comedic shorts, or they would focus on specific characters.
Okay.
Like there's one called Find the Crimson Four-Leaf Clover,
Okay.
where Team 7 helps Konohamaru find a four-leaf clover.
Oh, that sounds cute.
Yeah, it's a fun one.
Okay.
And then there's Mission Protect the Waterfall Village.
Okay.
That one's a bit more serious.
Okay.
It even got a DVD release in the US.
Oh, wow.
Yeah, they called it Naruto the Lost Story.
Oh, interesting.
And then there's Konoha Annual Sports Festival.
Okay.
That one's hilarious.
Okay.
It's got all the ninjas competing in like a sports day.
Oh, that sounds funny.
Yeah, it's really good.
Okay.
And then there's Hurricane Konoha Academy Chronicles.
Okay.
That one's like an alternate reality story where all the characters are in high school.
Oh, wow. That's a cool concept.
Yeah, that's a lot of fun. And then there's The Day Naruto Became Hokage.
Okay.
That one shows all the chaos that happened on the day Naruto became Hokage.
Oh, wow. That sounds interesting.
Yeah, it's a sweet one.
Okay, cool.
So yeah, the OVAs are definitely worth watching too. They're like
Yeah.
little bonus stories.
Cool.
So now let's talk about the music.
The music, yeah.
So for the original Naruto series, the music was mainly composed by Musashi Project and Toshio Masuda.
Yeah, I love their music.
It's so good.
Yeah, it's like really nostalgic for me.
Yeah, me too.
And they released like a bunch of soundtracks.
Yeah, there are a ton of Naruto soundtracks out there.
Yeah.
And they also released some best hit collections
Yeah,
with
right.
all the opening and ending theme songs.
Oh, cool.
Yeah, and some of them even had instrumental versions of the songs.
Oh, wow. That's awesome.
Yeah.
And then for Shippuden, the music was done by Yasuharu Takanashi and Yaiba.
Right. Their music is so epic and dramatic.
Yeah, it's like perfect for Shippuden.
Totally.
And they also released a bunch of soundtracks.
Yeah, tons of them.
Yeah, and like the movie soundtracks.
Oh, yeah. Each movie got its own soundtrack.
Wow, that's a lot of music.
It is a lot of music.
And I think it's worth mentioning the English theme song.
Oh, yeah, the one from Cartoon Network.
Yeah.
Oh, it's a classic.
I know, it's like so different from the Japanese themes.
Yeah. It's got its own unique style.
But it's so catchy.
Yeah, it's really nostalgic for a lot of fans.
Yeah.
It was performed by Jeremy Sweet
Okay.
and composed by him and Ian Nickus.
Okay, cool.
Yeah, so that song was like a lot of people's introduction to Naruto.
Yeah, it was like the gateway drug.
Pretty much.
So how did the world react to Naruto?
Well, it was a massive commercial success.
Right.
Like by 2011, Narahaya merchandise was making $200 million a year.
Wow, that's a lot of money.
It's a lot of money.
Yeah.
And by 2019, they had sold over 3 million anime home video units.
Wow.
Yeah, and it was a top performer on Hulu. And in Japan, Shippuden was consistently one of the most watched anime series.
Okay.
And Naruto was a top earner for TV Tokyo.
Wow, so it was like a global phenomenon.
Totally.
Yeah.
And by 2020, it was the third most watched series in the U.S.
Wow, that's huge.
Yeah, it's pretty amazing.
So what about the critics?
So the original Naruto series got kind of mixed reviews.
Oh.
Some people thought the animation wasn't as good as the manga.
Okay.
And they thought the pacing was a bit slow sometimes.
Okay.
But most people liked the fight scenes and the characters.
Yeah, the characters are great.
They are, and
Yeah.
the emotional depth of the story.
Yeah.
But Shippuden generally got better reviews.
Okay.
People thought the animation was better, and
Sure.
the story was more mature and complex.
Okay.
And they really liked the character interactions.
Yeah, the characters really grow and change in Shippuden.
They do.
Yeah.
And Charles Solomon from the Los Angeles Times, he even said that Shippuden was one of the top anime series.
Wow, high praise.
Yeah.
So did Naruto win any awards?
Yeah, it won a few.
Okay.
The original Naruto was ranked 38th in IGN's Top 100 animated series. And Viz Media's first DVD compilation got nominated for an American Anime Award.
Okay.
And Shippuden was nominated for Best Continuing Series at the Crunchyroll Anime Award.
Wow, that's awesome.
Yeah.
So we can't really talk about Naruto without mentioning the Naruto run.
Oh, yeah, the Naruto run.
Yeah.
So that's the way the characters run in the anime.
Right.
They lean forward and their arms are straight out behind them.
Yeah. It's so weird, but like it works.
Yeah, it's become like a meme.
Totally.
Like people have organized real-life Naruto run events.
Oh, wow, really?
Yeah.
That's awesome.
And it even became part of the Storm Area 51 meme.
Oh, yeah, I remember that.
Yeah, people were saying they were going to use the Naruto run to get past security.
Yeah, that was so funny.
It was.
Yeah.
So yeah, the Naruto run is like this weird cultural phenomenon.
It's crazy how these things take on a life of their own.
I know, it's amazing.
So I think we've covered like pretty much everything.
Yeah, I think we've hit all the major points.
You talked about the original Naruto anime and then Shippuden.
Right.
And the movies and OVAs
Yep.
and the music.
Glorious music.
Yeah, and like how the series was received.
Yeah, but critically and commercially.
Yeah, and we even talked about the Naruto run.
I love the Naruto run.
Yeah. So hopefully this deep dive has given you a good overview of the Naruto anime.
Yeah, we tried to cover all the essential stuff.
Yeah.
Without getting too bogged down in the details.
Yeah. So here's a final thought for you to think about.
Okay.
What do you think are the main reasons why Naruto has become so popular? Like, what are the themes or elements that have resonated with people all over the world?
Yeah, that's a good question.
Yeah. What do you think has made Naruto such a lasting phenomenon?
It's definitely something to ponder
Yeah.
as you continue your journey through the Hidden Leaf Village and beyond.
Awesome. Well, thanks for joining us for this deep dive into Naruto.
Yeah, it's been a pleasure.
And we'll see you next time.
See you later.
Bye. All right, so you wanted to know more about Greenland.
You got it.
That's what we're diving into today. We've really gone deep into the research here. Looking at its history, geography, government, you name it. We're going to try to extract the most fascinating pieces from a really comprehensive Wikipedia entry on Greenland. So
Give you the good stuff, yeah.
all the good bits. So you can really get a solid feel for Greenland without, having to dig through all the details yourself.
Yeah, it's a big topic, lots of fascinating layers to uncover. We want to make sure you come away feeling like you really know the place.
Absolutely, yeah. I think a good place to start is always with the name itself, Greenland. It actually has a pretty interesting backstory. Did you know that?
I did.
So way back, around 986, when Norse settlers, led by Eric the Red, landed there, they decided to call it Greenland.
Ronland.
Greenland, yeah. And it's widely believed that they chose that name, which is pretty optimistic, right? To entice more settlers to come join them in this land that might not have been quite as green as the name suggests.
It's a bit of a marketing tactic, isn't it?
Yeah.
You know, put a nice spin on things.
I mean, we do that today.
You do it all the time, yeah.
We do it all the time.
Make things sound a little more appealing.
But I think it's a really interesting contrast, though, when you look at the name that the indigenous people, the Inuit people, use.
Yeah.
Which is Kalalit Nunat.
Right.
And that translates to Land of the Kalalit, which refers to the Inuit people particularly of Western Greenland. So it really centers their identity, right? In the land itself.
It's not about attracting outsiders.
Yeah.
It's about who belongs there, who's always been there.
Yeah. Yeah, it's a very different way of thinking about place.
Yeah, it really highlights that deep connection, that sense of rootedness to the land.
And the history of Greenland goes back so much further than even the Norse arrival.
Yeah.
We're talking Paleo-Inuit cultures that appear as far back as 2500 BC. So really ancient history.
That's incredible.
You've got these Norse settlements starting around 986 that lasted for about 400 years. Then the Thule culture comes in around 1300, and they're the ancestors of the Inuit people today. And then, you fast forward, you get these waves of Dano-Norwegian exploration and colonization, then transition to being a part of Denmark, and then the move towards home rule in 79, and then self-rule finally achieved in 2009. So there's a lot to unpack.
Yeah, it's a long and complicated story.
Let's go back to those early Paleo-Inuit cultures for a bit, because it's kind of mind-blowing how far back they go. You've got the Saquak culture. They were really prominent in the south and west of Greenland from around 2500 BC to 800 BC.
Wow.
And a lot of what we know about them comes from digs around Disco Bay.
Disco Bay, okay.
Including a site called, the Sequoia site. And they had a really distinctive material culture. Their tools, their art style, it really sets them apart.
So we can actually trace those changes in culture and technology over time through archaeology, which is pretty cool.
It is, yeah. It gives us a window into how they lived and adapted to such an extreme environment. Then, at the same time, you've got the Independence Eye culture up in northern Greenland.
Okay.
From about 2400 to 1300 BC. Now, they were part of this broader thing called the Arctic small tool tradition. And you can kind of guess what that means.
Small tools. Small
tools. They made these intricate little tools. We're talking tiny, finely crafted things. And they even had dwelling sites like Delta Terresern.
Delta Terresern.
So they were settled to some degree,
It's amazing to think about how they were able to create these settlements in such a challenging environment.
It really is. And then around 800 BC, things shifted. And the Saquak culture fades, and you get the early Dorset culture in the west and the Independence Sea culture up north. The Dorset people, they were big on hunting whales.
Yeah.
And reindeer, too. So that suggests maybe a change in how they were using the resources, or maybe even some environmental shifts.
It's fascinating to think about how these different cultures were adapting to their surroundings, especially over such long periods.
Makes you wonder, did they ever cross paths with the Norse settlers who came much later? Like, the archaeological record's kind of murky on that, especially when it comes to the Dorset people.
Yeah, that's a big unknown. We know the Thule culture did interact with the Norse later on, but what about those earlier encounters? It's really intriguing to think about those potential interactions across vast stretches of time.
Yeah. Speaking of the Norse, their arrival in 986 under Eric the Red on the west coast, that's a pretty huge turning point.
Absolutely.
They set up these three main settlement areas. You've got the eastern, the western, and the middle settlements.
Okay.
All kind of nestled in those southwestern fjords.
Right.
Now, as we mentioned, this wasn't an empty land when they arrived. They were coexisting with the late Dorset culture and then the Thule culture, who were moving south from the north. And by 1261, North Greenland was under the rule of the Norwegian crown, which then became a part of the Kalmar Union, which is this big union of, Denmark, Norway, and Sweden. So there's this connection back to Scandinavia for centuries.
It's fascinating how those political ties stretched across such vast distances, even back then.
It is. And these Norse settlements, they actually thrived for a good few hundred years. Places like Bradley, which was Eric the Red's farm. It's hard to imagine those Viking outposts in that kind of environment. But then pretty abruptly in the 15th century, they just vanished.
Yeah, the mystery of the disappearing Norse settlements. It's one of the big historical puzzles.
It really is. And it seems like the Little Ice Age, that period of global cooling, probably played a huge part, made farming a lot tougher, sea travel riskier.
Right. It's a reminder of how vulnerable even seemingly successful societies can be to environmental shifts.
Absolutely. It's interesting, though, what we know about their lives comes from these sagas, these medieval Icelandic and Norse sagas, and other written accounts. We get glimpses of their economy, their bishop at Gardar. They even collected tithes.
Tithes.
Tithes, yeah.
Like religious taxes.
Yeah, exactly. And
Yep.
there's this 13th century Norwegian book, The King's Mirror, which is really interesting. It talks about Greenland's exports back then. Things like furs, walrus ivory, and get this, grain.
Wait, they were growing grain in Greenland in the Middle Ages? I thought it was too cold for that.
That's what I thought. Apparently they were trying to cultivate grain.
Wow. What kind of grain were they growing, and how were they pulling that off?
It seems like it was mostly barley. And they were growing it, get this, all the way up to around the 70th parallel. So pretty far north. And the last written record we have from the Norse Greenlanders is really kind of touching. It's this 1408 account of a marriage at Valsey Church.
Kavalzi Church.
Yeah, it's still standing. It's one of the best preserved Norse ruins there. And it's just this really human connection to that time.
Yeah, you can almost imagine them there celebrating that moment in history.
Totally. And those sagas, they paint such a vivid picture of life back then. But it's good to remember that a lot of those sagas were written later, like in the 13th century and after. So while they're great for understanding the later Norse period, for the really early settlements, archaeology is our main source.
Makes sense. You have to go to the physical evidence to get the full story.
Yeah, and the environmental data, like ice cores and clamshells, they back up that idea of a milder climate between 8800 and 1300. That's probably why they could do all that farming.
It really shows you how those small shifts in climate can make a huge difference, for better or worse.
Yeah, it's pretty remarkable. And then the climate did shift again. The Western settlement seems to have been abandoned around the time temperatures dropped in the 14th century. Summers got shorter, winters got harsher, made their farming lifestyle a lot harder to maintain.
Yeah.
The Eastern settlement probably lasted a bit longer, but it was eventually abandoned too, probably around the early to mid-15th century, maybe during a really bad cold snap.
So we know the climate was a major factor. But what else contributed to their disappearance? There are a lot of different theories out there.
Right. There are a lot of theories. Malnutrition, maybe worsened by soil erosion. They were farming, possibly the plague that swept through Europe. It might have reached Greenland. There could have been conflicts with the Inuit. The Norse called them Skraelings, which it's not a very flattering term.
I was just going to say, that doesn't sound very respectful.
No, not at all. And maybe even a decrease in support from Norway. All those things together could have played a part. There are even some who think maybe ship-borne raiders or maybe the Norse just weren't willing to adapt to Inuit survival techniques.
The Inuit knew how to live in that environment, that's for sure.
Exactly.
It makes you wonder, if they had been more open to learning from them, would things have turned out differently?
That's a good question. And then there's the possibility of intermarriage, a gradual blending with the Inuit population.
Right, which the genetic evidence does suggest happened to some extent.
Yeah.
But it's hard to say exactly when and how much of that intermingling occurred during that time period.
Exactly. It's all kind of wrapped up in the mystery.
It's like a historical jigsaw puzzle,
Yeah, we've got all these pieces, but fitting them together is tricky.
And some pieces might be missing altogether.
Totally. Then you have the rise of the Thule culture. They're the ancestors of most Greenlanders today. It's interesting, though, genetic studies haven't found any traces of the earlier Dorset culture in the modern population.
So they were completely replaced.
Seems like it, yeah, over time. And the Thule people, they were incredible migrators. They originated in Alaska around 1000 AD and moved east across the Arctic, reaching Greenland around 1300.
Wow, that's a serious journey.
Talk about a journey.
Oh.
And they brought with them some seriously impressive technology. The dog sled, for one, changed transportation forever.
What?
And the toggling harpoon. Much better for hunting those marine mammals.
Yeah, these innovations gave them a real edge in surviving in the Arctic.
A huge edge. And we know they interacted with the Norse, sometimes peacefully, sometimes not. We get those stories from Inuit oral traditions, and there are hints of these encounters in the Norse sagas too. So it's this picture of two distinct cultures kind of bumping up against each other.
Right.
And then from 1500 to 1914, we see this renewed European interest in Greenland. The Portuguese were among the first, Gaspar Cortereal in the early 1500s. He was looking for the Northwest Passage and ends up mapping parts of the Greenland coast.
Wow, so they were some of the first Europeans to really explore and document the region.
Exactly, and we see that reflected in early maps like the Cantino Planisphere. It's from 1502. And then a bit later, you have the Dano-Norwegian expeditions under King Christian IV, early 17th century. Their goal was twofold. Try to find those lost Norse settlements,
Yeah.
and reassert Dano-Norwegian control.
Makes sense. They wanted to reclaim what they considered theirs.
But those expeditions, they didn't really get very far.
Why not?
The Arctic conditions were pretty brutal,
Of course.
and it seems like they were looking in the wrong place for the eastern settlement.
Oh, so they were on a bit of a wild goose chase.
Pretty much.
It happens.
But by the 17th century, Dano-Norwegian sovereignty was back on. And a key event here is Hans Egede's expedition in 1721.
Hans Egge.
Now, this was a merchant and missionary expedition, and it really marked the start of a consistent Scandinavian presence in Greenland, the official beginning of Dano-Norwegian colonization.
So this is where things really shifted.
Yeah, and they focused on Godthab, which is present-day Nuuk.
Nuuk, okay.
And over time, Greenland was open to Danish trade, but pretty closed off to other European merchants.
So Denmark was really establishing its control over the region.
Yeah, they wanted to maintain their influence.
Yeah.
Then comes the Treaty of Kiel in 1814, which dissolved the union between Denmark and Norway. Denmark and Norway split, but Greenland stayed under the Danish crown. Then there's this kind of bizarre little episode where Norway occupies eastern Greenland in 1931.
What?
Yeah, it's this uninhabited area. They call it Eric the Red's land.
Eric the Red's land.
Yeah, they claimed it was terra nullius, no man's land.
Bold move. Did that fly?
Not really.
Yeah.
The Permanent Court of International Justice, it ruled in favor of Denmark's sovereignty over all of Greenland in 1933.
Okay, so Denmark held on to its claim.
They did. And then World War II comes along, and things change drastically.
Yeah, I can imagine.
Nazi Germany occupies Denmark in 1940. That cuts Greenland's ties to its colonial power.
Right.
So the U.S. steps in, and they occupy Greenland from 41 to 45, mainly to keep Germany from setting up shop there.
Strategic move in wartime.
Totally. They used the codename Bluey for Greenland and built some key air bases. Bluey West 1 at Narsarsuaq and Bluey West 8 at Kangerlussuaq.
Which are still major airports today.
Yeah.
So the U.S. had a lasting impact on the region.
Yeah, and this period really forced Greenlanders to become more self-reliant. They had to create their own systems during the war.
Makes sense. They had to adapt to the situation.
And then after the war, there's a big push for modernization, closer integration with Denmark. And in 1953, with the new Danish constitution, Greenland's colonial status is officially over. They become an amttiv, basically a county fully part of Denmark, and all Greenlanders get Danish citizenship.
So a significant change in their political status.
Huge change. But then Denmark starts this cultural assimilation policy, sometimes called de-Greenlandification. They promote the Danish language and make people go to Denmark for higher education, which kind of leads to some loss of Greenlandic culture.
Assimilation policies can have complex consequences.
They do.
Yeah.
And it creates a backlash in the 1970s. There's this growing movement for a stronger Greenlandic identity, greater political autonomy. And it really starts paving the way for independence. We also see a big expansion of the welfare state in Greenland, just like in Denmark. Free education, healthcare, progressive LGBTQ+ rights.
So mirroring the social changes happening in Denmark.
Yeah, it's an interesting parallel. And then there's that time the U.S. tries to buy Greenland in 1946. They offered something like $100 million.
Seriously?
Seriously.
They just tried to buy the whole island?
The whole thing.
Wow.
Denmark said, no deal.
Yeah, not surprising.
And then in 1951, the Greenland Defense Agreement is signed, so the U.S. could have their military bases there, most importantly, Thule Air Base. Which leads to that whole controversy about Project Iceworm, that secret U.S. plan to build nuclear missile sites in the ice.
Project Iceworm sounds like something out of a spy movie.
Right.
And they actually tried to do that.
They started, but it was abandoned, and Denmark didn't find out until much later.
Secret Cold War shenanigans.
Totally. And then there's that 1968 B-52 crash near Thule, nuclear weapons involved. contamination, an unrecovered bomb. It's a mess.
Yeah, that must have been a huge deal.
It really shaped the relationship between Greenland, Denmark, and the U.S. throughout the Cold War.
It's a stark reminder of the risks involved in those kinds of military operations.
And then things moved toward self-determination. Home rule in 1979, a local legislature with control over some policies, a referendum in 2008, more autonomy, and then self-rule in 2009.
So a gradual process towards more independence.
Yeah, not all at once.
Makes sense.
In 2009, they get responsibility for stuff like their courts, policing, natural resources.
Big step.
And crucially, Greenlanders are recognized as a distinct people under international law. They have the right to self-determination.
That's huge.
Huge.
It sets the stage for potentially becoming fully independent someday.
Yeah. Now, Denmark still controls foreign affairs, defense, and they give a big chunk of money to Greenland every year.
Right. So it's still a complex relationship.
Definitely. But the move towards independence is happening. In 2012, Greenlandic becomes the sole official language.
Wow. That's a strong statement.
And then there's that border dispute with Canada over Hans Island. Remember that? They finally settled it in 2022. They split the island.
They split it right down the middle.
Yeah, pretty much.
Wow. That's a pretty pragmatic solution.
Yeah, shows they can work things out. And Greenland had actually already left the European Economic Community back in '85.
Well, yeah, I'd forgotten about that. Why'd they do that?
Fishing regulations, mainly. And the EU's ban on sealskin products. They wanted control over their industries.
Makes sense. Those are pretty important to them.
Huge part of their economy. And remember when Trump wanted to buy Greenland?
Oh, yeah. That was a thing, wasn't it?
Back in 2019.
Yeah.
He said the people wanted to be part of the U.S. Polls showed that most Greenlanders disagreed, and Denmark said it wasn't for sale.
Yeah, that was never going to fly. But it shows how Greenland's strategic location is becoming more and more important on the world stage.
Exactly. And all of that history gives us a better understanding of Greenland's geography, too. We're talking about the biggest non-continental island in the world. Over 80% of it is north of the Arctic Circle. To put it into perspective, it's about the size of Western Europe, but with a tiny population.
That's a lot of wide open space.
A lot of space. Its borders touch the Arctic Ocean, the Greenland Sea, the North Atlantic, Davis Strait, Baffin Bay, Nares Strait, Lincoln Sea.
Whew. That's a lot of water.
It's surrounded.
So who are their closest neighbors?
Closest neighbors are Canada.
Okay.
They share a land and sea border on Hans Island. And then you've got Iceland.
All right.
And it's got the biggest national park in the world, the Northeast Greenland National Park.
Yeah.
Unspoiled wilderness.
Incredible.
The climate, it's kind of extreme. The lowest temperature ever recorded in the Northern Hemisphere was in Greenland. Negative 69.6 degrees C.
Wow. That's mind-bogglingly cold.
That's cold, yeah. That was in 91. Even in Nuuk, the capital, you're looking at below freezing in the winter to just under 10 degrees C in the summer.
So bundle up.
Bundle up. Then there's the Greenland ice sheet. It's massive. Covers something like 81% of the whole island.
Yeah.
2.85 million cubic kilometers of ice. Underneath it all, there are these enormous canyons. One of them is called Greenland's Grand Canyon.
A hidden canyon under all that ice. That's kind of awesome.
And the highest point in Greenland, Field, it's 3,700 meters high.
Wow.
And it's buried under the ice sheet.
That's a huge mountain.
It's amazing.
Yeah.
And almost all of Greenland's towns are on the coast.
Makes sense. That's where the ice-free land is.
Yeah.
Mostly on the west coast where it's a little milder.
Exactly.
But what about Peary Land? That's way up north, isn't it?
It is, yeah. It's in the far north. And it's mostly ice-free.
Why is that?
Super dry Arctic air. Doesn't get much precipitation.
Huh. Interesting. So even within Greenland, you have these microclimates.
Yeah. And then there's Warming Island.
Warming Island. That sounds ominous.
It is, in a way. It was discovered in 2007. It used to be hidden under a glacier that melted.
Ah, so climate change is literally revealing new land?
Yeah, it's a very visual reminder of what's happening. And speaking of the far north, there's this whole thing about what the northernmost landmass actually is.
Right.
Kefalogen Island.
Kefalogen.
It's recognized as the undisputed northernmost point on Earth. Although they keep finding these little gravel banks and other things even further north.
Oh, wow.
They pop up and disappear.
So the map is always changing.
It is. And of course, we can't talk about Greenland without talking about climate change. It's been warming since around 1900. And the ice loss, way more than the ice gain since the 1980s. Since 96, there hasn't been a single year where the ice sheet gained more than it lost.
That's alarming.
Yeah. And the melting in the 2010s was the fastest in at least 12,000 years.
We're talking about serious long-term changes.
We are. And there have been these huge melting events, like in 2012, 2019, and 2021.
Like unprecedented levels of melting.
Yeah, like a huge chunk of the ice sheet surface melting at once. And in 2021, it actually rained at the highest point in Greenland. First time ever recorded.
Wow. Rain at the highest point. That really hits home.
It's a big deal.
Right.
And all this melting, it's causing sea levels to rise, something like 0.68 millimeters per year between 2012 and 2017.
And that adds up over time.
It does.
Big time.
Yeah, projections show that Greenland alone could contribute 6 to 33 centimeters of sea level rise by the end of the century.
Depending on what we do about emissions, right?
Exactly. And it's not just the rising sea levels. All this fresh water pouring into the North Atlantic is messing with the Atlantic Meridional Overturning Circulation, or AMOC.
AMOC. That's the big ocean current system, right?
Yeah, it helps regulate global climate patterns, and the fresh water could slow it down or even stop it completely. And that would really mess with weather patterns in Europe and North America.
So potentially huge global consequences.
Huge consequences. And the Greenland ice sheet has enough water to raise sea levels by 7.4 meters. That's a lot of water.
That's hard to even fathom.
Hard to fathom, yeah. It would take at least 1,000 years to melt completely, but even with a small amount of warming, we could lose a big chunk of it, irreversibly.
So there's a tipping point we don't want to cross.
Absolutely. And then there's this study from early 2025. It shows that Greenland lakes are changing rapidly. They're going from blue to brown.
From blue to brown, what does that mean?
It's because of all the heat and rain.
Yeah.
It's changing the whole ecosystem of the lakes.
Chemistry, everything?
Chemistry, the biology, everything. And we're only beginning to understand what that means for Greenland's environment.
Yeah. It's a whole chain reaction.
Geologically, Greenland's is ancient.
Like really old.
Billions of years old. It's part of the Precambrian continent of Laurentia. The core of that is the Greenland Shield, these ancient crystalline rocks. And the ice-free coastal areas. They show billions of years of geological history. You've got Precambrian sediments, metamorphic formations, and then even younger rocks from the Cenozoic and Mesozoic.
Wow. So it's like a geological time capsule.
Totally. And there are signs of ancient volcanoes, flood basalts, igneous intrusions. The southwest coast is particularly interesting. It's got these unique rock provinces. And then there's Isucasia.
Kisukasi, okay.
This region has some of the oldest rocks on Earth, over 3 billion years old. And some really unique minerals there, like Greenlandite and Nuamite.
3 billion years old. That's
No.
hard to comprehend.
I know, it blows my mind. And in southern Greenland, there are these alkaline complexes. And around Evitu, they used to mine cryolite, which is a pretty special mineral.
I've heard of that. Isn't it used in aluminum production?
Yeah, it was really important for that. And then there's East Greenland. It's a gold mine for paleontologists. They found fossils of those first vertebrates that walked on land, like Acanthostega and Ichthyostega, and some really cool Triassic animals like Mystriasuchus alaroque, it was kind of like a crocodile,
Yeah.
and Isisonic, an early dinosaur relative.
So it's giving us clues about the evolution of life on Earth.
Exactly. It's
Yeah.
amazing. Now, when it comes to biodiversity, Greenland has two main ecoregions, the Kalat-Nunet high Arctic tundra and the low Arctic tundra.
High Arctic and low Arctic, got it.
Not a ton of insects, only about 700 species.
Compared to more temperate regions.
Yeah. But the marine life,
Yeah.
it's teeming, thanks to the West Greenland current, which is full of nutrients, loads of seabirds.
Ah, so that's what drives the ecosystem.
Yeah, that current is key. Land mammals, not as many. You've got the iconic ones, polar bear, Arctic fox, Arctic hare, musk ox.
What classics?
Yeah, the classics. The collared lemming, ermine, Arctic wolf. Those are mostly in East Greenland. Reindeer were introduced by Europeans. The waters around Greenland.
Yeah.
Loads of seals and whales,
Mhm.
crucial for the ecosystem in Greenlandic culture.
Right.
And then there's the plants. Grasslands and shrubs, mostly. They're good for grazing livestock. The hardiest tree is the European white birch. It's not very big, but it survives. Around 500 species of higher plants. And tons of lichens.
Lichens are pretty cool. They can survive almost anywhere.
They're tough. And on top of those native animals, you've got the Greenland dog, brought over by the Inuit. And then the Europeans brought sheep, goats, cattle.
So a mix of native and introduced species.
Yeah, and the marine mammals are really important. Hooded seals, gray seals, a whole bunch of whale species. Beluga, blue, bowhead, fin, humpback, mink, narwhal, sperm, pilot.
Whoa, that's a long list. They've got it all.
They do. And about 269 fish species, mostly marine. That's why fishing is the biggest industry in Greenland. And the bird life is also pretty impressive. Seabirds like auks, puffins, skuas, kittiwakes, and then you've got migratory ducks and geese. Land birds like the Arctic redpoll, ptarmigan, owls, garfalcon, white-tailed eagle.
So much diversity.
So much. Let's shift gears a bit and talk about government and politics. So Greenland is self-governing, but it's